Time for questions. In this lesson we answer the things beginners always ask about Helm, Kustomize, and Argo CD, grounded in how Amazon EKS recommends you run them. 8 common questions, answered directly, including whether Helm and Kustomize can be combined, what OCI is, what an application set does, and how rendering actually happens. Grounded in the Amazon EKS Argo CD guidance. First question, can you combine Helm and Kustomize? Yes. A very common pattern is to take an existing Helm chart, render it as your base, and then layer Kustomize overlays on top for your environment-specific tweaks. Why would you? Because you can reuse a published chart without forking or modifying it. Why would you not? Because you now have 2 tools to learn, and for a simple app that is often overkill. See the combination. The Helm chart produces a rendered base. Then a Kustomize overlay sits on top, merging in your environment-specific changes. The output is the final set of cluster manifests. This is exactly how many teams consume a third-party chart safely. They never edit the chart itself. Second question, can Argo CD render both? Yes, natively. Argo CD renders Helm charts and Kustomize overlays out of the box. Your source of truth can be a Git repository, a Helm registry, or an OCI image. Argo CD pulls it, renders it, and applies it to the cluster. That is the GitOps pattern. Git is the source of truth, and the cluster converges to it. Here is the loop. Whatever your source of truth is, Git, a Helm registry, or an OCI image, Argo CD pulls it, renders the manifests inside the cluster, and applies them to EKS1 controller, both tools, fully native. You never build a separate render step. Argo CD renders both Helm and Kustomize natively. Third question, what is in-cluster versus off-cluster rendering? In the default, in-cluster model, Argo CD does the rendering itself. Inside the cluster, it runs Helm template or Kustomize for you. In the off-cluster model, your CI renders the manifests first, then commits the raw YAML to Git, and Argo CD simply applies that raw YAML. The off-cluster, or rendered manifests, pattern gives you stronger control and a cleaner audit trail, at the cost of an extra step. See them side by side. On the in-cluster path, Argo CD pulls Git or Helm or OCI, renders, and applies, all inside the cluster. On the off-cluster path, your CI renders first, commits plain YAML to Git, and Argo CD only applies that plain YAML. No Helm or Kustomize needed inside the cluster at all. Many regulated environments prefer the second, because what runs is exactly what was reviewed. Fourth question, what is OCI? OCI stands for Open Container Initiative. It is the standard format for container images, and registries like Amazon ECR speak OCI natively. The important bit, since Helm 3, a Helm chart can be packaged and stored as an OCI artifact. So your chart can live in a registry, versioned and pulled just like a container image. See the flow. You take a Helm chart and push it to an OCI registry like Amazon ECR, then anyone, a developer, or Argo CD itself, pulls a specific version, exactly like pulling a container image. The chart becomes an immutable, versioned artifact in a registry, rather than a folder in a Git repo. Fifth question, how do you split templates and OCI? The clean pattern is a split. You author your charts in a Git templates repository, chart.yaml, templates, overlays. On release, you package and publish them to an OCI registry like ECR, then Argo CD consumes the registry, never your mutable working tree. This gives a clean separation. Git holds the source, the registry holds the immutable releases. See the split. Developers edit the templates repository in Git. On release, charts are packaged into the OCI registry. Argo CD and the clusters consume from the registry. The two never mix, authoring happens in Git, consumption happens from the registry. That is the clean, auditable split Amazon recommends. Here is Argo CD consuming a Helm chart that lives in Amazon ECR. The repo URL points at the registry, the chart field names the chart, and target revision pins the version, just like an image tag. The capability role needs the Amazon ECR pull-only policy. This is straight from the EKS Argo CD guidance. Git for source. OCI registry for releases. Argo CD consumes. Sixth question, what is an application set? A single application deploys one thing to one place. An application set takes one template and generates many applications from it. For example, the same app across dev, test, and prod, or across many clusters. It generates them from a list of environments or clusters. So instead of writing 3 near identical applications, you write one application set. See it fan out. One application set, defined once, generates an application per environment, dev, test, prod, each pointing at its own cluster or overlay. Add a new environment to the list, and a new application appears automatically. This is how teams scale Git ops across many targets without copy-pasting application definitions. Here is an application set in code. The generators list the environments: dev, test, prod. The template describes one application, with a placeholder for the environment. Argo CD generates one application per element, each pointing at its own overlay path. Add an environment to the list, and its application appears, no extra copying. 7th question, which should you learn first? If you mostly consume published charts, learn Helm first. If you write your own plain YAML and just patch it per environment, learn Kustomize first. It is simpler, with no templating language. But ultimately, learn both. In any real GitOps setup, they appear together, and you will need to read both. 8th question, where do secrets go? Never in your values files or overlays. Git must stay clean of real secrets. The standard pattern is external secrets operator with a vault. On AWS, you back it with Secrets Manager. External secrets operator syncs the values into a Kubernetes secret automatically. Argo CD then just references that secret by name, the same way it would any other. Charts in a registry. Secrets in a vault. Git stays clean. 9th question, do you need a cluster to practice? No. Helm template prints YAML with no cluster. Kubectl Kustomize prints YAML with no cluster. Everything in this entire series is practicable locally, for free, with no permissions. You only need a cluster when you want to actually apply something. Beyond these questions, here is what to ask yourself next as you design your own setup. How will you split source and releases, Git versus OCI registry? How many clusters, and how many environments, do you actually have? Do you need an application set yet, or are single applications simpler? And where do your secrets live? Answer those 4, and your architecture is mostly decided. Quick recap. Helm and Kustomize combine. Helm is the base, Kustomize overlaying on top. Argo CD renders both, from Git, a Helm registry, or an OCI image. In-cluster rendering happens inside Argo CD, off-cluster rendering happens in your CI, then raw YAML is applied. OCI lets you store charts as versioned registry artifacts. And an application set fans one template out to many environments or clusters. A small exercise. Pick one chart you publish. Push it to a registry as an OCI artifact using Helm push. Then point an Argo CD application at that registry, instead of at Git. Confirm that Argo CD renders and applies the chart straight from the registry. Once you have done that, the Git versus OCI split clicks into place. One controller. Both tools. Git, Helm, or OCI as the source. Render locally for free. Apply to a cluster when ready. That wraps the Q&A. In the final lesson, we bring the whole series together and tie it back to where we started.